How many of you have done hollow farms? Okay, you guys sit in the back of the room, because I want to talk to everybody else. No, I'm serious, only from the standpoint that hollow farms is a whole process. And typically, like Bill Walter's piece, you're doing a lot of hollowing through an opening that you can't see the tool. So we call it blind turning. And it's blind turning because you can't see it. And then measuring the wall thickness and getting everything right and uniform is also hard. And then you look at the calipers that don't fit like the other kind of calipers fit. So it becomes a technical challenge. So I don't do pieces big like this, except I saw one piece of wood that Bill brought out there that I would really love to do, only because this is end grain. And the grained fibers are facing this direction. So when you're turning, if you're working downhill to the grain like I keep teaching, downhill is to here, downhill is to here. So I'm pushing against the end fibers if I'm not careful. I got all sorts of problems in trying to deal with stuff like this. And then you get stuff like that. So I don't do pieces like this normally. But there is a piece out there that would just, I don't know who's going to get it, but it would be turned cross grain. It's dark wood, and there's a little bit of sapwood right on the side. And you've turned that into a hollow vessel, cross grain, you would have a beautiful little white collar here on the top. But with being cross grain, the wood's going to be moving this direction, but not this direction. So the chances of it ovalizing out is real high. Yeah. So you do what we call two-stage turning like we do with green bowls. You turn it, let it dry, put it back on the lathe later and fix it, hopefully. Sometimes you don't get the opportunity. But hollow forms is just another art form. And some people, I saw a lot of bowls, and I'm delighted to see the hollow forms here today, only from the standpoint that, to me, this is a terrific art form. And it requires some technology and some techniques to do it. I'm more likely to turn something like what Bob Nolan did. This is more the size of things I would work with. So I'm bound into, you get a big piece of wood for that, I'll take the scraps off of it and work with the scraps. Now, you still have to do the same thing. This piece of wood requires the same technology, but it's smaller. I can't check the wall thickness, even my little finger won't fit in this one. But you still have to do the same thing. And to me, I like working with the smaller forms. It's just what I've chosen to do as I've gotten older. But one of the things that makes the job easier, especially on these bigger pieces, is using some mechanical advantages along the way. So what I want to talk, first of all, a little bit about how tools cut when you're working on an end-grain piece like this, and the different kinds of tools and how they cut. And then I want to talk a little bit about how to do a hollow form using some of this stabilized boring systems. Now these stabilized systems help you control a bunch of the things you have to do. You want to be at the center line when you turn it. Get a little too high, get a catch. Get a little too low, it doesn't cut so good. And if I got a tool that's kind of hanging over like this, then there's the tool wants to torque a little bit. So I got to stabilize that so it doesn't move in my hand. There's all sorts of mechanical things you got to deal with. So I really don't know when this is. I almost called Lyle to ask him, but I didn't. Frank Sudol, a turner that's passed away a number of years ago, used to turn hollow forms. They stood this big, this tall. I'm indicating about 4 feet off the ground. He turned a very thin wall and then carved them. And it had to be thin walls so he could carve through them. But Frank couldn't possibly have done anything like that by hand. So he developed a stabilized boring system. In fact, the lathe was in one room. The control of the thing was actually in another room. It was that big. It was that huge system. Well, that's something we would never have. And we would never contemplate ever having something that big. But a man named Lyle Jameson in Traverse City, Michigan, decided that, you know, if this thing is scaled down to the size that we normal turners have, we could all benefit from the same technology. So Lyle developed a system which was introduced, and I don't know how long ago. First time I met Lyle, I know it was about 25 years ago. And I was talking to him at a club meeting. He was here doing a demonstration, not here, but for this club, doing a demonstration. And I'm asking him to explain to me how this laser thing works, because I don't get it. And he holds up a coffee cup and goes through a visual demonstration. I said, oh, well, really? Oh, cool. I got it. So 25 years ago or so, Lyle Jamieson introduced commercial systems at a fairly reasonable price that we could all fit onto our lathes. He's handled the stabilized, so it doesn't do this. He's handled keeping it at center. And he's found some way to be able to measure the wall thickness as you go, and that's where I'm going to take us to today. Now, a lot of people made their own, because it's not that hard. You do just a little bit of metal working, you can weld up a piece. A few years ago, some of our club members, one of our life members, Robert Woodworth, and his partner, built a system on the same style, but instead of being a long rectangular thing, they made it, yeah, I'm afraid I can't even lift it anymore, out of a round bar, instead of being rectangular. So this stabilizes it so it doesn't turn. And this gizmo, I'll explain to you later, is how we hold a laser for measuring purpose, and I'll show you how I do that later. I don't use this one, this is way too big. They made a smaller version, which I do use. I didn't go into the storage room, but we have one in the storage room that's made as a copy of Lyle Jamieson's original piece. One of our founding members years ago, Bill Charlton, welded up one. It's pretty crude, but it looks just like it and it works just fine. And so our club members had talked to Lyle Jamieson well over 20 years ago and said, you're making these great systems. They work great for the bigger lathes. What about all these people who have the 10 and 12-inch lathes? You care about that market? And he said, no, I don't care about that market. Would you mind if we made something that would be useful for those people? And that's where the O-bar system came, to fill a need, and then of course they upscaled it. They were in business for maybe 2 years under the name of Turning Ways and then went away. They just were not successful business-wise. On the market today, there's maybe 6 or 8 systems, of which about 3 or 4, I'll mention the names later, are really viable products that can be purchased in some place in the range between $300 and $500. Some of them go up as high as $700 and $800, but they all do exactly the same thing. They keep your cutter level, they keep it from torquing, and they give you a way of being able to measure wall thickness so that you can tell where the heck you are. And of course they got to have enough movement that you can get into all those nooks and crannies of this curved piece. And adapt to a lot of different kind of cutters. Well, the thing right now is really popular is carbide. So I want to talk a little bit about carbide cutters as we go along too, because when I'm working inside one of these hollow vessels, almost 90-some-odd% of the people are scraping, because all the cutters are scrapers by the nature of the way they work, with a couple of exceptions. One way manufacturing company makes a thing called the termite, which is a little round donut-shaped cutter that has a bevel on the back. And literally you put that inside and you literally are rubbing the bevel, remember the word, so we've all said it in class. You're really rubbing the bevel and cutting on the bevel of the tool. It's one of a couple of exceptions. My problem is that little hole fills up with stuff real fast and it's a pain in the neck to keep it clean. But that's one way. The other one is the traditional tool that goes way back into the Middle Ages, and that's the hook tool, which is also a bevel rubbing tool. But since it's more shaped like this, and we have a bevel, at least one side's open so the stuff can get out, and it's easier to keep clean and make those cuts. Difficult to learn to use. Any bevel rubbing tool where you can't see it, it's inside of something, is difficult to learn. So 99% of us don't do that stuff. We scrape. And since all carbide cutters are scrapers by nature, they work perfectly well. Not only perfectly well because they hold an edge better, they work even better than some of our high-speed steel cutters do in that application. So I want to show you how to cut. Then I'm going to show you how I set up a stabilizing system. And then I'm going to add the laser to it to show you how I measure the wall thickness. And then I'm going to show you my modification, because everybody's always modifying things and coming up with new ideas. And I'm going to show you a way to make the laser work much more efficiently than anything I've seen on the market. Where's Hugh? Hi, Hugh. He and I have been in conversation about how do you do that. I said, all things will be revealed. So, we've got about an hour plus, and I'm going to take you through those steps. So the first thing I want to do is show you how pieces cut. I've got a bowl, which is basically, it's an end grain bowl. So in essence, it's a hollow vessel with the top cut off. So we can see how that tool cuts. So I want to show you that first. And then I'm going to show you the tools I use for hollowing and how they vary a little bit. And since I do mostly small things, I've taken a lot of the big tools that you might use and scaled them down a little bit so they're easier to work on these smaller pieces that I tend to do. The Bob Nolan size stuff, maybe a little bit bigger. The transitional vessels I do not ever get hollowed in the traditional way because I do them in two pieces. And I'm turning them like two bowls and then gluing the two halves together, so I never have to work through a small hole. It's a little different. But when I do a hollow vessel out of something like this, and some of the great looking pieces of wood I saw outside, I'm encouraged to take on another big project, only from the standpoint the wood is too delightful out there to pass up on. So looks like everybody can leave tonight with only if you take a piece of wood. Two, there's another, two maybe. Okay, so I'm going to ask Robin to focus on the inside of this piece of walnut here, originally. So the grain on this is going like this. So what we're looking at and seeing here is all end grain. So this would be like hollowing out the bottom of a hollow vessel. So we'd be working this portion here. This is the part we cut away. So I just want to show you how they cut. So if I go in there with something just fell off.
Your microphone.
Your left. On the ground to your left.
Trying to grab the wire. I trust lighting on the bed. There we go. Okay. So if I try to do this with a bowl gouge, a normal bowl cut, rub the bevel. And on this piece, I can come almost that far around before the edge of the tool runs into the edge of the piece. So at some point, this part out here is going to prevent me from being able to stay in that traditional cutting format. So what else can I do? Well, I can cut this way, but that's cutting on the edge and there's no bevel support. I do that sometimes, but I just recognize that it's up to me hanging on rather than support from the tool. I could open up the tool like this and get bevel support. You see how the edge is hitting that wood? That's a super huge cut, and what we call a catch waiting to happen. So that's a high risk. That's a high risk cut. So we don't do that. We do it with hollowing tools, and there are. I brought both sets of mine. We have tool sets back here in the classroom, bigger than these. I scaled mine down. Here's my medium size. Here's my small size. I said scraping is what we do. And on overhead, maybe, for a second. Ooh, overhead didn't. Overhead? We have an overhead? Different overhead. You got an overhead? Okay, well that will work. Don't have an overhead. This is a typical, what we call an Ellsworth style hollowing tools. It's a piece of steel bar.
No, that's it.
I bored a hole through on this one at 45-degrey angle. It's held in by a set screw from the end.
I wonder if I can just take this out. I wonder if that'll fit. Yeah, it should. I think it's on the bottom. I don't know why they moved it forward like that. I had it all the way back so you can get this thing off. You have to take this off.
Let's see if we run out of battery.
Oh, did it work?
I get it all the way back so you can take this.
I think you need to put the wire under your shirt.
Oh, we can hear you fine now.
Okay, yeah. So the way this is going to cut, and this is the other one, this is a straight cutter. And this one is set up at 45, or about 45 degrees. The point is that when I have to go under a curve, I've got to find some way to be able to cut underneath the curve, and that's what this tool will do. Now these cutters, you go to a place like MSC Industrial or KBC Tools or any of these places and buy these are probably 1/4 inch high-speed cutting bits, and they cost about $3 or $4. And they're made out of nickel steel or high-speed steel, all those different kinds. That work. And all I've done is cut them in half. Well, I didn't cut them in half. It's pretty hard to cut this stuff. You can use a cutting wheel and it'll separate it. The easiest thing to do is take and break it and snap it. And then I sharpen these on our typical CBN wheels. And by sharpening, first of all, I just shaped it just round. In the back, I just ground some fairly arbitrary angle. And yeah, underneath. Right before I started today, I sharpened them. And to do that, I simply took one of my sharpening stones, actually I got from Rockler. They sell these in 3 or 4 different grits. They're diamond impregnated plates. I think they're around $15. And they come in a bunch of different grits. The one I like most is called Fine. It's red. And for about $15 you can carry this with your credit cards in your pocket. And every time you have to sharpen one of these bits, I'm just stroking up the back side of your face. And that pushes enough of an edge up. I never really have to ever go to the grinder. This bit has been in here for probably years. And it does the job. So let me show you a cut. I'm going to turn the speed down to 0 because I don't know where it's been. Okay, it's a little bit out of balance. It was just fine yesterday. I could true it up, but I'm not going to. I'm just going to show the cut. So I want to be at center line. You can see right now with the tool rest sitting where it is and the tool horizontal, I'm low.
Hey,
Not
Jeff.
by much.
Jeff,
Yes.
can I ask you, have you ever considered a flat bar or a square bar, maybe to reduce helicoptering of the tool?
No,
No.
I haven't, because these straight tools do not helicopter. These would, but the farther this tool hangs over, the more likely it is to helicopter. So I keep it fairly short. My intention is this looks like it's sticking out about 3/8 of an inch. In fact, it was sticking out farther yesterday, and I took it to the grinder and shortened it. Point of which is to keep it from doing that. The other solution for that on small vessels is to have a handle that's big enough that you can hang on to, and to prevent the tool from hanging over the tool rest too far. All those are which are mechanical supports that you have to work at. So in essence, let's get some speed on this thing. That looks pretty level, pretty good speed. I'm a little right at center line. Now the trick is, I want to keep this tool level. The moment I allow my hand to droop, I'm in trouble. Or if I get over and press it, just get down here and see what I'm doing, I've got the same problem. So I want to keep it level. At home I have a short bed lathe. I could have moved the headstock down on this one, but for later things I didn't want to do that. But if I can support it with my body when I make the cut, oh, my hands are wet. So I'm going downhill to the grain, actually. It's laying like this. This is downhill from the bottom up. If I went in like this, sure it cuts, but I'm cutting into the ends of the fibers, and that's not as clean a cut. So to open this hole up, I'm going to use the straight tool. So most hollow vessels, we drill a hole so we have a place to start, and then we make the hole as big as we can. And then we use the tools to keep opening. So I'm in the hole. Hold it down to the bottom here. Now, when I'm in in a vessel and I can't see that thing, I have up on the handle a felt marker. And that felt marker tells me where level is. So when I can't see this thing, I don't know if this is level or not, I can see my felt marker on the handle and I'll know where I'm at. So opening this up, so the process of hauling includes a lot of different actions, but the first thing is just removing junk wood. Now I'm in a deep vessel and I've got a small tool, and it's going to look more like this. Okay. Oh, good. You know what that is? That's too much tool, too small, too far over the tool rest. So the solution to that is to go to something that's heavier, bigger in diameter, more mass. Well, I'm trying to stay out of the way here. So that's making a little bit of noise. I might actually need a bigger bar for being this far from my work. For big vessels, I have at home a bar that fits in one of my stabilized systems. That's 1.25 inches in diameter. It takes 2 hands to put it up. But when I'm working way over the tool rest, it don't vibrate. And that's the whole point. The farther off you stick, the bigger the diameter the tool needs to be to keep that vibration as low as possible. So the straight one's great for opening up. Come back to the normal position here. If this was curved, I would probably be using the one that would helicopter over here. And my hand on top is not helping Robin with the camera. So I use this for a lot of the finish cuts where the curve is now interfering with my ability to get the straight tool in. So this is a limited application, but typically for under the neck of a piece, where I have to come up underneath this curve, this area in here. I can't sometimes reach with a straight tool. Here down, I'm doing just fine. So it's this area up in here where I have to go from this out to this curve that sometimes needs that bent tool. So for some of you, I'm preaching to the choir, but let's go on with the example here. So anyway, if I'm opening this up, well, I shouldn't be looking, should I? Because in a real vessel, I wouldn't be able to see at all. So you begin to rely on sound. You begin to rely on feel. Now the sound's pretty uniform, so my cut must be pretty uniform as I'm coming around. I'm really not looking. And I'm also not trying to rush this. I'm moving nice and steady. Now I'm coming out. If I was working on Bill Walter's piece, you'd be able to watch my tool move. Because one thing Dave Ellsworth used to do was cut a hole in the side of his vessel when he was doing a demonstration so that you could actually see the tool work. Anyway, so that's the different kinds of tools. Now these are scrapers. Just standard high-speed steel onto a bar. We did a master's class here with Dave Ellsworth many years ago, and actually we were using these tools. And I said, Dave, I'm doing it right. He said, yeah, fine. They're just like mine except smaller. Go ahead, John.
The tool that you were just using that comes out of 45, can you actually take, or are you keeping that straight in for the cut, or do you just sort of turn it just a touch, tweak it to so it's on a downhill cut?
Okay, John's asked, do I keep this straight across, or do I turn it slight downhill? The thing is I don't want to do is turn it up.
Oh no, but I'm just
Once
saying.
I turn it up, I'm going to have a cast. So cross is great. Safest is down a slight bit. So if I'm slightly below, in fact, here's my pencil mark. And if you see the angle of that cutter, maybe you can't. But it's hit by the shaft. There's horizontal, there's horizontal. Overhead camera probably would have caught it, but anyway, it's slightly down.
Turn it the other way around on the tool rest.
Won't cut.
I know, but if
He
you were,
meant to show.
just move, there you go.
Ah, oh, I see. Mine's still hanging working here. Okay, so here's my mark. And that tool is down at, take my word for it. We got all sorts of different camera shots, and none really illustrates what I'm trying to say, but it is slightly down angled.
Okay.
A little bit, yeah. In fact, when I'm really worried and I'm working in a piece that I'm very close to the end, I might rotate it even down even farther to become more of a negative rate scraper. But good question, and that's a good point. I never thought about turning it around.
Couldn't you grind one so it was a negative rate scraper?
Yes. Well, I've never found the need in hollow vessels for a real negative rate scraper. When I do small pieces, one set I happen to like is very, very unusual. And it's made by a company, run by a man named Kel McNaughton. They're called Kelton Hollowers. This is maybe a good overshot, here. This is the miniature set. And this is just tool steel. And on the top 1/16 of an inch is a piece of high-speed steel that has been just fastened to the surface. This tool steel handles the vibration really well. They come in 3 different sizes. There's a straight one, there's a slight bent, and a much more aggressive bent. Can't get the other one out of the picture there. Anyway, come in sets of 3. That's the small, which I do use a lot. That's a miniature. There's a small. This is the medium size. And on this one you can actually see the brazed on piece of steel. So it gives you a lot of mass back here. So these don't vibrate a lot. And I use these. I brought along 2 of these. I had a large set. And I loaned them out to somebody a couple of years ago and never got it back. So put a handle on this thing. Of course, it's much more massive. That's exactly the same one. Can't see it. Can't do that one. Anyway, that's the medium size. Kelton Hollowers. Lee Valley Tools. I don't know if you can buy them anymore. They're coming in from Australia. Kelly used to call me every now and then and see how's it going. But his tools now are limited. So here is the bent version of that same tool for going up underneath the deep shoulder. When you use a tool like this, never rest it any place on that curve. It will helicopter on you. So you always have to rest it behind this portion here. Now, back off just a little bit, Robin. Just a smidge. Back off just a little bit. Yeah, good. This cutting edge right here is intended to be in line with the shaft. So if your cutting edge is in line with the shaft, you will not get that helicoptering effect. But if I rest it here, I got a problem. If I'm resting back here when I'm cutting, I don't get that and I'm downhill again. Hear that lower sound? That's the wood. If you hear vibrations, listen to the sound. 2 things I'm going to tell you. It's high frequency, it's your tool vibrating. It's a lower frequency, it most likely is your wood, your project vibrating. And so the longer they get, they go thump, 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 thump. You know it's the wood is doing this flexing thing of its own. Yeah. But anyway, that's another set. Okay. These are traditional tools. We did a master's class on hollow forms a couple, 3 years ago. Several people in here were in that class. And this is definitely overhead. we have tools like this. The overhead? Oh boy, what did I do that for? Yesterday I had strength to be able to loosen that. Today I apparently do not. Anyway, change the lens. These are carbide cutters. These come from Hunter tools. These are called pocket rocket miniatures. Look at the beveled angle on this one right here. You can't see it too well, but the tool is shaped like this. The cutter is at 45 degrees, so the angle's already in there. Mike Jankowski makes these,
Right.
and they're sold through Craft Supplies in Utah. You still can buy them. They're still real good tools. Mike Hunter makes another one like this, which is much heavier duty. Tilted down, creating that negative rake again. So if I was going to use one of these, all I have to do is use an appropriate handle. This is a straight one. Now we can go back to the end camera. And the end camera. And you can see that that's angled down in this plane. It's not rotated, but it's angled down 10, 15 degrees, something like that. I've never measured it. So again, high speed, high sound. What's vibrating? Tool. As you get closer to the rest, that vibration goes away. Nice thing about these carbide cutters, they don't get dull very fast, and they are all 360-degree discs, which means you can loosen the screw, rotate it a degree or two, and tighten it back up again, and you've got a new sharp edge that you don't ever need to sharpen. I have found I actually can sharpen these. I take them off of here, lay this face down flat on one of these 600 grit diamond hand cards, and lap it. Don't try to touch the edge, just lap the face. But you can sharpen it. But if I can get this out of here, I have to put a different one in. Who's got better grip?
Michael.
Joel is going to step to the point here.
I'm sending Michael.
Mike is going to step to the point here. This Mr. Strong Fingers.
I don't know, I've been too much
Trade you that for a glass of water here.
too much chainsawing this week, I don't know. Oh, righty tighty, lefty loosey?
Yep.
I moved it a smidge and then...
And I tightened it myself.
Maybe it goes off the other way.
Boy. Anybody want to give it a whirl?
We'll let it. Forget about it. I'll do another one.
I'll cover that with a cloth or something.
Well, here's a different one. This is from Hunter Tools, and he's relieved the side over here to give you more clearance to the edge. And if you see the tip of the tool, it's down at 30, 40 degrees. In other words, it's canted, so it's not going to catch. And it's a fatter shaft, so this is going to go into here, this little demo piece, with much less chances of catching it. And my hands are in the way. And go into the hole. Very cool. So I would say that if you're doing small pieces, look at these things from Hunter, Craft Supplies, anybody that has these interchangeable tools. I like the Hunters. I don't know why. I just happen to like the brand. I get a lot of different options. The square one is really great because it's got even more mass. It has a tendency not to torque on the tool rest, But being square, it needs a larger diameter handle. So where this one would fit, this red handle, this one won't. It needs an even bigger one. It's all a matter of just having the right handles and interchangeable.
Do they make a hook tools yet?
Hunter, yes, he does. I just don't use them. I just don't choose to use them. But yeah, they do. So a few years ago when John Cobb was wanting to do a class, he wanted our own custom tools. So I made these. John bought the replaceable cutters. You want these online. You buy them with the screws because the screw is designed to fit the shape of that hole and hold it nice and solid. You? Comment?
Yeah, do you like the carbide cutters more than the high-speed steel tool bits? You find you use one more than the other?
Yeah, oh, that I can answer that question. The first question I'm thinking about. But I do tend to use the high-speed steel bits a lot more. I'm a traditionalist. I'm happy with them. I've been using them for a long time. The cutters that are carbide cut more rapidly.
Yeah.
And I sometimes like them to cut not that rapidly. I mean, they're more efficient sometimes than what I would like. So I think answering you, that's a great question. I prefer the high-speed steel cutters or the McNaughtons because the McNaughtons are just really, I just like them. I've used them for years. They're real stiff and so on. Yeah.
When you buy the tool bits, do you get the ones that have the cobalt in them, or do you just buy high-speed steel?
I think for what our use is, high-speed steel is good enough. If you want to get the bits that have some cobalt in them, that's also okay. It doesn't matter. My sharpening is always with that card that's laying on the floor. Or the spare one was laying here someplace else. I had another one. Oh, yeah, here it is. It's too obvious. These things are my sharpening. And it's a stroke up, and basically I'm kind of pushing up the burr. I never try to hit the face because I will mess it up and it won't be flat. The moment I do that, I'll get it wanky. So if I go to the grinder at all, I'm shaping for the back edge, only to shape. And then the sharpening is always with one of these cards. And I did them right while Steve was making the introductions, sharpen them all, just a few strokes up with the card. And that's adequate for me. So I think typically, Hugh, that the carbide tools cut too efficiently for my liking. Now, if I'm doing a piece like heavy oak, and it's a big piece like that, and I've got a lot of material to take out, I might go to the most aggressive cutter I have, just simply to hog out a lot of stuff. And then I'm getting down to getting my final 1/4-inch wall ship thickness. I probably then would revert back to a cutter that's a little less aggressive. My choice. So anyway, good questions. So please keep asking here. But anyway,
Be careful when you sharpen those for your final cut, because it cuts totally different and faster. And you can think you're only cutting a little bit, and you happen to be cutting
a lot more, yeah. So here's one of the larger McNaughtons, and my sharpening, and this is the middle size set. And this piece right here, never want to go to the grinder with this thing because there's not that much metal. As I told you, it's only about a 1/16 or a 32nd thick. My sharpening technique, I'm just pushing up to the back side along the edge, and I picked up a sharp edge, just that quick. But I'll never hone this face. I just don't need to make it not flat anymore. Right. Again, choices and so on. Dave uses the McNaughtons too, I know, on some of his smaller pieces. I have found that they're just stiff. They cut about as much as I would like to cut, and I'm just happy with them. It's unfortunate you can't buy them in a lot of places like we used to. So for me, it's more useful sometimes to have some of this mechanical holding things taken care of for me. And the moment I have to hang on to this tool, I am going to get tired from that a certain amount. So why don't I just make all that go away? Now we're getting into the systems. I'll leave this here for a second, doesn't matter. So it'd be nice to have a stabilized system. And it consists of, first of all, a backrest. This is a piece that sits back here on the lathe. A little piece locks it underneath. Now, my tool's going to sit in here, and I've got it at an angle so I can go all sorts of different places. So that's going to keep it from torquing, and it's also going to keep it running level. Well, sounds like a nice idea. Well, let's see, what else do I need? Oh yeah, I need something that'll sit in there. And so my cutting now, this is a good overhead shot. Good overhead shot. Okay, so here's my back brace. I got all sorts of room to be able to move this tool. Now I adjusted it and waxed it yesterday, so it's good for this bar here. The one out there on the table is bigger around, and so I had to shorten the distance between these things, so I didn't spend a lot of time rattling. The other thing I need is I want this cutter to be right at center line. Well, I'm looking inside that hole. That's closer to center line. I have a tool in here. It's a bigger bar. It's got two holes in it, one on the end and one at 45 degrees. So I actually don't even have to change cutters. I can just now pull that thing out and stick it in the other hole. Bob?
I take mine, pull it back out, and measure the tip off the top of your wing. You got a 10-inch lathe, 10 inches. You got a 12, it's 12.
It better be close to 12 here because this is a 24-inch lathe.
Well,
So,
that's what I'm saying.
one of the
Whatever size
adaptions-
lathe you got, you can adjust it to.
One of the adaptions I had to do is the largest lathe I have at home is 20-inch. And when these back braces were built for me by Bill Tarleton years and years ago, there's all sorts of holes in them. And that means I could adjust it from a 10-inch lathe all the way up to the biggest lathe on the market, which is 20. That's not true anymore. This is a 24. So I had to have a new back brace built Thursday actually, that will allow me to get this thing tall enough that I can keep level. So that says I'm a little heavy, a little high. The other thing I can do, I can put one of these Wixies on it, a little level,
See, it's not level.
and set it for 0, and to get it horizontal that way. Everybody should have one of these things really nice. Huge.
Jim, you need a pin on the back side of that.
To stop it.
Yes.
Some of the
Put nails in there.
some of the brands have a device out here to keep you from accidentally pulling it out.
Yeah.
And I understand that. My habit is to grab it back here and drive it like this. But for safety, I think a couple of brands have a clip that'll go back here, and I could manufacture one. That would just prevent it from ever coming out of the back brace. So right now I've eliminated most of my problems. I've got a system that won't rotate. I've got a system that is level. And I've taken out some of the mechanical work I've had to do.
And it's
So-
smaller now.
See if it works. How you doing, Ed? I don't have to worry about it. Now, the one thing that is working for me is feel. I'm in the hole. I'm coming out of the hole along that bottom, coming around the curve, and I'm up to the side, and now if I'm going to come the rest of the way out, I got to back straight out. So I'm doing this by feel. One thing that does is if you get a bump in here, you will feel it. So begin to start relying on your sense of touch, and well, touch can't get there. Feel. See, now I can check out who's asleep and who's not. But in essence, I've eliminated a lot of the work. And this particular shape isn't anything that's necessary. The one that Lyle Jamison makes is shaped like a long rectangle. Other people have other shapes, and they all do pretty much the same. And it doesn't matter. But I've eliminated all the work. I can literally sit down in a chair, and I used to do this. I'd sit at the lathe and drive this thing and do my hollowing without any effort at all. So you see, picked up a lot of advantages here. I chose to use the smaller bar rather than the larger one because I never used that one. My pieces are such that this seems more comfortable to me for the size pieces that I'm used to making. Anyway, how we doing, you? So far good?
Okay,
So far so good.
you do things a little different than I do, that's all. It all works.
Yeah, and there's so many different systems on the market, and there are things that you can just make yourself. You don't need a system. Where's the hole? Well, there's the hole.
Seems like all the systems that are commercial are big and long. Like, I don't have a lot of space, you know? Somebody brought a Lyle Jamison over, and it went almost into the wall, which, you know, if you don't have a giant lathe, if you have, I have a 16 over the bed, and that would make much more sense.
There may be a few of these still in the market available. People might want to sell you what they're not doing anymore. This is no longer in the market. This was a custom made that existed for about 2 years and disappeared. I had 2 or 3 of them, and I think I've sold them and given them away. Jesse, you have a point?
Yeah, I was going to actually comment on what she just said. We sell one of Rockler's Robert Sorby brand, but there's other ones out there that actually fit in your tool rest, and it's called a steady rest, and it's 2 offset ball bearing wheels, and it allows you to use your carbide tool, and you can just push it in. And it does not take up a lot of space at all.
Simple Wood Turning Tools makes one that fits in the tool rest that does not require back support. So everything pivots from this point here. They have a whole bunch of interlocking arms that do that. One way's pretty much for big lathes, but it works. Trent Bosch's system, which is available from Colorado, also works off of the tool post, and it has a piece that clips right here. It doesn't have one of these big back frames, so it works in a shorter mass. Lyle Jamison's original ones look awful like this, except that they're rectangular. And they need this back brace. My lathe at home is a 20-inch. And it's jammed into a pretty small area. So I don't have a lot of room either. So one of the other reasons to going to the smaller system, it's lighter and I don't handle heavy stuff too well anymore. And also I have enough clearance, which is nice. I'll post, Elbow makes one too. The Elbow 2 is another nice system. What brand was yours? You use the Sorby?
Robert Sorby.
So Sorby's, I know about their platform stabilizer, but I didn't know they had a hollowing system. Okay.
Steady rest. I think that's his name, steady rest.
Yeah, it's a small platform here, and it has a roller system on top, which tends to grab your tool here, and it's the only thing you do. So you use a standard handled tool through here. This platform and these rollers capture your tool and keep it from rocking. And it fits into your tool post. It's one of the less expensive ones because it only has one mechanical part, basically. Yeah. Forgot about that one. Let's go to a hollow vessel. I wrote all this stuff down because they're there. You can look for stabilized wood boring systems, and they'll all come up. The one I had the hardest time finding was Trent Bosch's, which is probably the most popular one on the market right now. It's a nice system. So let me just get rid of this piece and put something in that has a smaller hole. Don't need that. So here is a small hollow vessel. Turning the tool as long as it'll move. Oh, that's it. It won't go any farther. So that's it. this thing in here, more like real life. Right center line. So I've got a lot of mass in here. It's not hollowed down at all, so that the walls are still pretty doggone thick. Oh, that's not well done. So what did I do wrong? I didn't get it centered in the chuck. So someplace one of these jaws is not touching. So I'm going to find a different place to grab it. Push it in solidly. Feed down, test. Looks better. Still off a little bit, but that's probably just the moisture content changing. So it's out of line inside too, so the whole thing is off. So for just removing stuff, the straightener works just fine. Bottom. My holes go to about 80% of the depth I want, so I don't go all the way down to where the bottom's going to be. I figure I'm going to cut away some stuff as I work, so I just do this. Across the bottom. Rounding at the bottom. Get up to the wall. There's a little bump down there. So a lot of that's my field. And I have a very specialized tool. I got a smaller one too, but it's just a piece of aluminum rod. But you got to get the chips out. If you're doing green wood, it turns much easier, but the chips really load up in there and you've got to keep moving them out. If they load up, it'll pull your tool right away from the surface and it won't cut. So literally chip removal is a matter of making it cut too. Anyway, so that works pretty good, but you know, I really can't see what I'm doing. Oh, cutters, oh, it's in there somewhere. It'd be nice to know where that cutter is. So let's find some way to fix that. I need to add something to my system here to make that work. Let me think about that. How about putting something like this in it? And tighten the screw. And with this gizmo, I could put a laser on there. Well, let's see what we got. By the way, if you go commercially and buy a laser, that's red. That's red and a little brighter. That one has no batteries. This one right here, I bought on Amazon as a set of 3. This one is red. I got one that's green and one that's blue. I spent $8. So they are really cheap. This uses a AAA battery, so they're standard batteries too. So, nice thing about a triangle-shaped lathe bed, everything falls off. So I can put this in here. And turn it on. And if we're overhead, now this is the place where overhead would be really helpful. Overhead. 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 It's the other one. One left. Yeah. Can you see?
Yeah.
Well, wouldn't it be nice if I put that laser right on the tip of my tool and tighten all these funny little things here? Where is it there? Oh, lost it. There it is. So now when I'm in here working, I know exactly where the tip of that tool is. Cool. Step one. So, oh, there's the bottom. Coming up the bottom. Now you can see it easier. Well, that tells me the inside wall about there, it looks pretty straight to me. It doesn't look like it's curved in very much yet. So I can play with that a little bit. Now it doesn't show up really well in the camera, but boy, right here, it's really bright for me to see. Well, that's nice. And it's telling me exactly where that tip is. Now, what if, there's my cleaner outer thing.
Jim,
Yeah,
can you use the laser to know how thin you've gotten, or do you
Yeah.
still make the calibers?
what a great idea.
When it goes outside.
What a great idea.
That's right. You know, you
So
go
let's
outside.
assume I want to know how thick this is right
I'm
here.
telling too early.
I'm paid the $5 later. So if I want to cut right here, the tool is sitting at that angle. Tangent to the surface of the wood would be about this angle here. So if I set my cutter out here, my laser out here, that's what I'm trying to say, and lock it.
Yeah, it is.
Right now, that looks like about 3/8 of an inch. So if I go inside the wall, it's still on the surface of the wood. I'm not down to 3/8 of an inch yet. What happens when I get to 3/8? Well, let's see.
You can go right through.
Let's see. Robin, can you see this?
No, really just the top.
Well, right now that spot is getting kind of long. It's sliding down the side of the wall. A lot bigger here. Let's show 3/8. The laser beam just fell off the side of the vessel. It's no longer visible. So the light is tangent to the outside edge and exactly that distance from the cutter. So I now have a wall thickness gauge, which is really cool. So if I wanted 3/8, I don't want to cut there anymore. But if I want the rest of it to be 3/8. I can make this hollowing pretty fast. Oh, right there. Now I'm at a different place, and right now, the cutter is in that place, and the laser needs to be tangent to that surface, and it needs to be at this angle. Well, it pretty much is. But sometimes as you move around a curve, that angle keeps changing. So what you got to do, loosen all these things, get a piece of paper or something over here, and readjust that laser until you get it right where you want it. See if it'll stay there. Then you tighten it. Oops, that's not it. That's about it. Tighten. Nope, that's all. That's about it.
Don't loosen yourself.
Don't listen to two of them.
No, that's a little off.
That's the,
You got the point. So, that's the way most of them work. There's a couple of exceptions. One I developed, of which works for me, and the other one is the one-way. One-way has a fixture up here that's 360-degree circle, and you set how far away from the tip of the cutter you want it, and you can rotate this thing, or the laser, around, so that as the surface changes angles, I can still stay tangent to the surface.
Oh, that's cool.
Yeah, it's really cool. You can buy it as an accessory for a couple $100. That's one way to do it. I like that.
You can buy lots of gear for Halloween.
You can buy a lot of stuff for that amount of money. So I was saying, what else could I do? I want something that's both stable and adjustable. So I went and bought this. It's a laser gun sight. And what it has on it is two knobs. One is for adjusting windage, and one is for adjusting elevation. Windage, elevation, X, Y. So I turn this thing vertically, it's X and Y. And I can turn little knobs. And why a gun sight? This whole system is vibrating a lot. And these cheap lasers that I buy for $8, well, of course I can throw them away and get another one. This is designed to take vibration. Some pretty heavy vibration when a rifle is shot. You've got a lot of force. This is designed to take that kind of punishment, and this is the kind of punishment I'm giving it. So I bought a laser gun sight. And it got a charger, and it's got a chargeable battery in it, and I could plug it in, and I could put a remote out here that turned off and on. That's kind of a pain in the neck. So I just simply made a little bracket. Drops it here.
How much are we talking?
$40. $40. Actually, I can't get it in here tight for some odd reason. It doesn't fit. Anyway, there it is. Now, I don't care what all these things do, but I am going to turn it on, and I am going to, oh, there it is, way over there. I'm going to get it right on the tip of the tool. And the reason is just give me a starting spot. And I'm never going to touch those knobs again. So it's right on the tip of the tool, and oh, I actually see it on the camera. So now, here's my 3/8 wall. Remember, we just turned that. How do I get to 3/8?
Sure.
Well, that's moving it in and out that way. I want to get this in the center of its rotation. What I didn't do is put everything back. These knobs provide a range. And the best place to start is figure out where the center of this rotation is and start there. So you got full motion left and right. And that's what I didn't do. So let me just find center for a second here.
Is that block of metal designed for this fitting?
It's designed specifically for this because I made it.
Is it aluminum?
The gun sights come with a dovetail fitting. And it comes with the attachments to allow you to screw it onto the top of a rifle. That's true. But I wanted to put it into this round hole. So I have basically a square peg and a round hole. And what I did is I could either push it real hard or I could make it back a bracket. So I made a bracket. This is just round. You could do this in wood easily, turn it out of a dowel. And then this could be cemented to a block of wood. It'd be just fine. So now I want to take back what I said about aligning it. And align it now. Okay, that's close enough. I know that's 3/8, so all I got to do is done. Now when I go down to another area, if I want a different wall thickness here, that's moving it back and forth that direction. Now X and Y right now are this plane like this. And I could rotate this over and get it lined up. That would have been easy enough to do just to change the angle of this thing. So to me this worked out. Charlie Saul's not here today, is he? Just too bad. Charlie and I, he looked at my video on doing this and went out and bought one. So he's adapted it. I'm just using a sharp tool rest here, but there's my 3/8 down to there. And there I'm not to 3/8 because I'm still on the wall edge. So my solution was simply And I like the off-on button on the thing rather than the remote for some reason. I just went and bought this
It's the manufacturer.
gun sight. And I got it from Amazon, and I spent less than 40 bucks. It's got a rechargeable battery in it. I plugged it in last night just to be sure it was charged. And it had been sitting in the box for a couple months, and it was just fine. It's like 80%, so it's still sitting there. So, and you just plug it into USB port to charge. To charge it off USB. So I thought that this was a useful thing, because fiddling, you never get it quite right. Or you're messing with it more than you would do something else. So to me, being able to adjust this and know that it's going to be very stable because mechanically it's designed to be working on something that has a lot of vibration, not vibration, shock, that's the right word.
Concussion.
There's a lot of shock in it. This is not going to fail under these circumstances. So that was my adaptation here, and basically all I did, right in front of that, it's no good. This is a dovetail fitting, and this knob locks it down. And there's a piece that comes with it that you fasten to the barrel or the receiver on your long gun, and then this just slides on and off. Well, I made a block that had a matching dovetail on it. And on the other end, I turned a post that would fit into this carrier. It's clear to me that it fits the other one fine. This one seems to be a little undersized, so it slips in fine, but it's a little snug. And that's fine, but I would like it to slide in easily. Yeah.
Could you place that back on the laser and show us at the very bottom of the hole?
You want to see the laser like this?
No, I want to see the laser pointing to the very bottom of the hole.
Easy enough. So the laser is in the holder, and this should be the overhead again, Dave. So there's the dot. Now if I had this sitting right, oh, it's right on the tip of the tool. Let's get it right on the tip of the tool. Right there. If I want to know where I am, we know that's 3/8 because we measured that with the laser earlier. And we know right here that, ooh, the wall thickness is pretty thick. And the base, the bottom of the hole is right there.
When you're doing that cut at the bottom of the hole, is there only the, like my particular tool is a little bit, like it's a 3/4 inch round, and it tends to want to grab on the other side. I notice you have a really thin-headed type cutter right now.
Well, one thing about the stabilized system, if I get it dead on center line, it's not going to leave that little mountain in the bottom because it's going to cut right through that. When you're doing handheld tools, if you are slightly above or slightly below center line because of just moving, you'll leave that little mountain in the center, and it's a heck of a job to get that out. The smaller the tool, the harder it is. So a big round nose scraper is the best one to go in there. I would go in the vessel at the very end with a round nose scraper, straight in, big one, and I'd feel that little mountain. And I just push the handle straight down, literally leverage it off like this. But it doesn't happen much here. The biggest problem at center line is going past center line. And if you go past center line, the piece wants to pick the tool up and do this. So it's going to pick it up, bring it around, and slam it back down on the tool rest, which happens to all of us. So the key is just don't go past center. Thank you.
Have you found that that laser lasts much better than the little cheap ones?
Yeah, and what the little ones fail most is not for battery life, it electronically fails. They just get vibrated to death. So I've never worried about batteries in the little ones. They're a AAA battery, it's easy enough to change. But I've never lost a battery, but I have lost them. And I've had two of them I used to use. I put one in and it shuts itself down eventually. Take it out, put the other one in. And I keep switching them back and forth. Eventually they come back to life again. It's some Something about electronics not liking to be used for wood turners. It's picking on us. So. But I'd switch the two back and forth. That worked fine. But this one has never failed me. And it will run for hours. Imagine with a gun sight, you're out hunting. You're not going to fiddle around with turning your sight on and getting it sighted in when you see game. You're going to set it up when you leave, and you're going to have it running all day long, and just hit the button when you're ready to shoot. You know you already got it set. Yeah. Joe?
So on my system, there was a neat little small scraper that would attach to the end of the bar, just like you have that one. Rather than a big, a lot of times you can't fit that through the hole.
Well, also sometimes you want to just have a really smooth surface inside. Overhead again, Dave. Here is one of a number of round nose scrapers.
Right.
And when I can put this in place of the tool and make one or two small strokes up inside, which smooths out that area. That's one. Don't go away. Oh, there's lots of options. Another tool I can put into that area is this, which can be rotated from straight to an angle. This one I got from Lyle Jameson. This would fit into here, and then you can just rotate. It was easier for me just to change the toolbar. He also has a round nose scraper that fits in there. I have 2 or 3 of these. And the purpose of that is simply, on the very end, make a stroke down through there, eliminate some of the 80 grit sanding. Start you off with a fairly fine grit sanding. Yeah. Good question, good point. So my thing is I don't do many hollow vessels, but when I do hollow vessels, I like to do it as easy as I possibly can, and to me this setup eliminates almost all of the mechanical work I have to do. The one thing I do have to do manually. Keep forgetting which knob is off and on. I gotta clean the chips out myself. It's a lot of hard work.
Here's a tip for the chip cleanout. Is I have an adapter. It's for cleaning out computer keyboards, and so it's a cone shape that goes on my shop vac.
Yeah, I don't like blowing stuff around. Oh, you're sucking it out.
I'm sucking it out, and
That's fine.
it makes it so much cleaner and easier, less dusty.
I understand. But also when I'm doing this,
You feel it.
oh, there is a shoulder right there. Because I'm feeling the inside as I run along here, and I know this is round until right here. And this is where I stop playing at 3/8. I don't know where that is, but it's right there. So using this tool, or the small end or the large end, I'm in a position of being able to always kind of keep feeling my work as I go along. And I like feeling it. Yeah. So just some observations. This is the original laser that came with these. Years ago, the makers put a piece of plastic rod around here that would hold the switch on. Come down here, rotate it. That's supposed to keep it on. And it works pretty good. I made a, I don't know if it's laying here, probably not. I made a little round, yeah, it's not here. I made a little round aluminum disc that will slide down over the shaft, which will do the same thing. In terms of cleaning out the bottom, here's a couple other internal scrapers. These come from Sorgan, and I like the shapes a lot. I have some on handle tools. This curve from here to here, I don't know what that curve is, but some part of this angle is going to fit the exact shape of that. And it's probably 10 degrees. It's a very slight angle on this thing. To sharpen it again, you go to your diamond plate and you hone it. Don't try to play with the edge on anything like that. So I've got these kind of guys that also will do it. Other questions? I'm running out of stuff to tell you. Yeah?
So, obviously these are made for hollowing, but can they also be used for open form molds, to eliminate just, constantly using the, various measuring devices to measure?
Yeah. I can't use the measuring devices quite as well, but if I'm cutting out here, I have a nice stabilized boring system, and the laser's going to shine someplace other than at wall thickness. It's going to shine up on the vessel itself. So the laser's not going to help you on the exterior. But the stabilized system certainly makes it a lot easier than other ways. For instance, I can cut this shape right here. Very easily. But my laser is, if I wanted to, well, I'm just shaping. I'm not worried about wall thickness at this point. So I could do that, yes.
Well, just for example, to limit it to use of the laser for measuring wall thickness, that would work for an open form bowl as well as.
Oh, absolutely, absolutely, yeah, yeah. Because anytime you're inside, that laser could be on the outside, giving you wall thickness on any project at all. I changed to a hollow vessel just to have something that is hard to see. And right now, that area done just with this tooltip is not bad. It's pretty smooth. There's a lump right here I can feel. And right here's where I stopped working on it. So from here down, it still needs to be hollowed out some more. But anyway, it's just, hollow vessels are a lot of fun, and they are I'm glad to see the pieces come in today because it represents an art form. And every shape is just fine. But the key is, now this is not the way I think this needs to be. This has a base that's much larger than what I want. So my last cut on this thing is to pick up from right about here and reduce this down to maybe 2/3 of this diameter. But I've kept it large to keep myself mechanically supported as well as I can. And right before I part it off, I'm going to bring this down and do my final sanding on this last portion. And then part it off. And then, how do you get this piece off of here? One last thing I wanted to show you. Where the heck did I, oh, I see it. Several years ago, San Diego Woodturners had a project. I think I got the right Allen screw here. This is, what's out here? This works for bowls, but mostly it's designed for hollow vessels. This fits into the Morse taper. Oh, there's the piece. Set it over here and then walked away and forgot about it. This slides over here. This sits all the way on the bottom of the vessel. Then this cone is brought down to stabilize the neck. And I have my live center here.
Nice. That's cool.
It's got everything you absolutely need to hold this other than that last 1/16 of an inch.
And if you put sticky sandpaper on the end, it holds it better.
Yeah, yeah. See if that's the right, yeah, that's the right. I haven't used this for a long time because I just generally can do it by hand. There we go. So if I was going to do this, I have the tailstock on here, that's set there. How do you keep it centered this way? Push the cone down in. And now I have a system that's holding that dead center. The only thing I had to remember to do is to leave my little mark on the bottom of this when I turned it between centers in the very beginning. Like on all of our bowls, we always want to leave the mark on the bottom because we need it at the very last step. But right now, San Diego made this. You can buy these bars with a Morse taper on the end and turn this cone. They'll sell you with a faceplate here. And you turn this cone of your own dimension by wood. That didn't come out right. You turn this out of wood to your own dimension, so I should have said. But it provides a very stabilized way to complete this bottom. You're back between centers. They're most stabilized, most supported means. San Diego Woodturners don't build this anymore. They did it for a profit maker for a long time. But I found them online. Without this, but just with this, it says drill a hole in the center, slide a piece of wood over here, shape it down so it's kind of conical, and you've got your final support piece.
Cool. If you make it out of Delrin, you can use it to finish, where you can't if it's wood.
Yeah, if it's made out of Delrin and you're slopping finish on it here, it won't mess this up. Out of wood, it'll start messing up. The Delrin won't hold the finish and it can be cleaned off easily. So Delrin's a good choice. Yeah, other comments, questions? Yeah.
On your boring bar, he was talking about using it for the outside of the bowl. I was thinking you can also just put modify the boring bar just a little bit, put a drawing under, so use it almost like a pantograph to shape the outside of the bowl.
That's a good idea. So his point is, just take the laser and set it way out here and trace a line on a piece of paper that's clamped to the bed of your lathe, and that'll give you the shape. You can take a drawing out of a book, lay it down there and trace it out. That's a good idea. I hadn't thought of that at all. I like that. Yeah, Bob.
I got the same system, but I took a hotel credit card or key card, turned it around upside down, and just put a straight line across it. And so I could measure my distance from my laser to the cutter for the thicknesses rather than try to measure it every time. I just put increments on the back of the hotel credit card so I could.
So Lyle Jameson has a card that he gives with his
If
system.
anybody needs that, I may give it away because I'm going to buy one of them lasers. Jim?
Lyle's card has a line that goes this way and a 90-degree line going this way. And the idea is the 90-degree line is lined up with the face of the wood. In other words, it is parallel with whatever that curve is. The 90-degree line then gives you a place to position your laser this way. And you can mark it off a quarter or an eighth or something. You make your own out of a piece of cardboard. But it is helpful. I've been doing it with my thumbnail. Of course, Lyle says, well, it hits the blood in here and the spot of the laser bleeds out. And it's not as clean and tight as if it was shining on something that is not somewhat translucent like our body is somewhat. Hugh?
Do you find that the laser beam from that is finer, less fuzzy than the cheap ones?
They're about the same. About the same, I found. But when the cheap ones, when I got them and shining them up on the wall, the three I got as a set were all about the same dispersion. I bought another one from another place, and it had a tighter spot. But tighter was smaller and less bright. So it didn't work out that well. This was a real nice one I bought. It has actually a keeper on it to keep you from hitting the button. But that's really bright. That's big. That's a big spot. Down here on my wood, that daggone thing's almost an eighth of an inch across. So if I was going to use this laser, I would take a piece of paper, put it over here, and take a pin and punch a little hole in the center and make it an iris for it. So this is a great laser. Man, I'm looking at stuff in my office back there, but that's got to be 6 inches across back there.
That's big.
But at this distance right here, it's just a fuzzy blob. And I don't think it's suitable for our purpose.
Would it be good for the dot to be the size of your quarter-inch?
Sorry again, I wasn't listening.
Would it be good for the laser dot to be the size and round of the quarter-inch cutter?
No, because I'm really looking at the side of the dot. Wish I had a drawing board here. The dot's round. So this tangent point right here, and the cutter's round, and that tangent point right there, those two locations establish thickness. Anything that's not in this line is not in your thickness measurement. It's off. So that's the problem. As the curvature of the vessel changes, you got to keep moving the laser so that this round point and this round point are constantly opposite each other. Otherwise, if I move my laser way over here like this, I've got a false reading and I may go right through the wall by not moving my laser. The problem with this system, it works fine. But the problem is I got to keep moving the laser as the shape keeps changing. And so these knobs make it one heck of a lot simpler for me. Yeah, Joe.
So I looked on Amazon, that unit comes, there's one that has a red, green, and blue laser.
Well, that makes all the difference in the world.
I'm just wondering.
Use the green for green wood. Redwood. Keep going, we'll help you out here.
I'm just wondering, is there an advantage to a certain color laser one over another?
I don't think so. When I look at them online, they advertise them as cat
toys?
Cat toys.
Harass money.
And they're thinking that the colors is just it's a marketing thing to us human beings who are trying to entertain our cat.
Well, they do the same thing for your gun thing.
I have some colored ones here. I had that set of 3, and I didn't find anything any different. The red is pretty bright. The green seemed to be a little less irritating.
Yeah.
For the eye. And if you are sensitive to some colors more than others, you might have a preference for one of the 3 over another one. That's a good point. Yeah, red for redwood, green for green. Oh, yeah. You can make quite a story out of this thing. There's an article in there somewhere, right?
So, Jim,
Yeah.
when you turn it around and you want to
Trace a...
when you want to make the thickness smaller on the bottom of that vessel, can you utilize the laser to do that?
At the bottom, at the very bottom?
At the very bottom.
Yeah,
So
what I do is...
mark where the
I know what
inside
this is
wall
going to be here, and I know I want to be a 1/4 inch bottom thickness.
Yeah.
So I bring the laser a 1/4 inch out from here, and it's measuring thickness.
So you
Now, it
can
doesn't run off the side, but I just have
use that then on the outside to shave down the outside till your laser disappears or whatnot.
Yeah.
Okay.
But for the very dead bottom, it's never going to run off the vessel, but if I want it to be a 1/4 inch, I just know when the laser's a 1/4 inch from where my apparent bottom is.
Right.
Stop turning. Yeah, good point, yeah. In all those places, they work really fine.
Cool.
It's just a technique, and I have found this to be convenient for me. I don't turn super huge pieces, and I don't like a lot of work. And this tends to make it really, really simple. And I do like the feel of going in here, pulling those chips out. Hear that? That's where I stopped turning down to 3/8, and I've left a shelf. So one of the things that Dave Ellsworth and other people who teach hollow vessels teach you is you come down and work this vessel in stages. You get this first distance to exactly where you want it, and you stop. You've left a shelf. That tells you when I run that tool in there that I can't see right where to start turning. Pick up that shelf, go down and create another shelf and take it down to final dimension. And as I run my tools lightly down the side, I can find where I need to start the next cut. So the idea of hollowing and leaving shelves, even though I have a laser, I still do it. It's habit. It's the way I learned 20-some odd years ago, and that's just the way I continue to do it. But leave the shelves. I do the same thing on bowls too. I'll take the first 1/2 inch down, get it complete, then the next 1/2 inch, and just keep leaving little shelves. Gives me a place to put the tool.
Well, if you leave the shelf, only go part way down in there, you only have to adjust your laser 3 times, maybe 4.
Yeah, yeah. So Bob's using the same system and he's doing the same thing. Did you use that on your little piece?
Pardon? No, I didn't.
Did it by hand?
Yeah, the big base that I had at the gallery, to the library, I used it though.
So I brought along another piece, which doesn't go with the chuck. This is a bigger chuck. It's got dovetail jaws, so it holds it a little bit differently. So here's another project, the same. But imagine here I've got to come like this and out, and before I finish hollowing the inside, I got 2 choices. Am I going to make the inside kind of pointy, and then bring the outside down to a way I like it and just live with what the wall thickness is? Or am I going to turn the outside down to final dimension and then bring the wall thickness down to match? Or do I care? And for a lot of my pieces, I kind of leave the inside thick, and I turn the outside down to final dimension, knowing that I have plenty of mass inside, I'm not going through the wall, and I'm going to end up with a heavier bottom, which is appropriate for a vase to keep it steady. So I don't bother sometimes down in this area on the inside near as much. If it's kind of a little bit pointy, that's okay. I'm going to take this off on the outside.
And also, doesn't doing shelves reduce the vibration as you go down? Because if you go all the way down and then you want to come back up, your wood you've got too much vibration. So I took a class with Mike, and he says, you leave the bottom bigger on all of there.
Yeah.
So that as you go down, you've got less vibration because now your sides are sturdy and not wobbling in and
We'd
out.
love to get Mike back up here to do another workshop, and he's much more reluctant to travel than he used to be.
Right.
The last time he was here, he stayed at my house, and let's go out in the shop and turn a vessel. Okay, let's turn another one. I was dead when I went to bed. He wanted to go out there and keep working. He's a great guy. So these pocket rockets, these little Carbide tools are made by Mike Jankowski and sold through Craft Supplies, probably other places. They come in sets of 3. He has a larger set,
He also has a
Hollow
bigger,
Pro, I think he calls
he
it.
has a bigger bar also with
Okay.
a
Three
different
sizes.
cutter on the end. That's
Three sizes.
cardboard.
Yeah, 3
Carbide.
sizes, yeah. Okay. So in essence, this one is very rough on the outside, hasn't been sanded, hasn't been perfected. It's pretty much turned. There's a spot down here that's thinner than the rest of it. I don't know where it is, but it's in there. So I'm not going to work on this anymore. I'm going to give this to Steve. And somebody can have that. And where's Steve?
He had to,
He left.
Okay, he had to leave? Okay, then we'll do this any way we want to then, right? Are you going to do this? Here's the piece I had on the lathe. This has been sanded and kind of polished on the outside a little bit, but we know it still needs to be turned down some more. This is the one I just had on the lathe. We're good down to about here. So I got 2 hollow vessels here, neither one of which I'm going to work on anymore. So these become your giveaways. And if you don't like what I've got, there's lots of wood out here to shape your own. So anyway, come on up and look at the tools and all this stuff when you get a closer look at them. But basically, I was just sharing with you some of my experiences. I never used this system here, but I have used the shorter bar because sometimes, like Cindy, I've got a place where I'm kind of cramped for space. This one is a little shorter, it's 6 inches shorter than the other one, and it fits my working space better. It also limits my ability to bring things around a little bit. Okay, so I'm done. You've got a little bit of work to do.